Hello and welcome to this video to help you smash your OCR GCSE Computer Science exams. In this video we're going to cover the Comp 1 June 2023 paper. But before we get to that, we have an excellent offer to help you smash your OCR Computer Science exams. Over the Easter holidays we have two sessions based around Paper 1 and Paper 2. There are going to be 3 hours of taught lessons by a teacher who gets result in the top 5% of the country. Now, you might think that'd be quite expensive, but we're doing a superb offer. For 3 hours of lessons, so that's two 1.5 hour lessons, we're doing it for £40, which is a lot cheaper than we normally would. The sessions are on the 15th of April and the 17th of April, and they're from 4 o'clock to 5:30. So they're really cheap. If a teacher gets us the top 5% of the country, we will link down below to that course. You can get yourself booked onto it and help you smash your exams. Now, let's look at the June 2023 paper and go through it to help you get ready for those exams in a few weeks' time. Hello and welcome to this little video which is going to go through the May 2023 paper 1 for OCR GCSE Computer Science. Now the front of the paper is pretty important to get this right because you want to make sure that your marks get back to you. So a couple of things we're going to talk about on the paper. We've got to put our centre number and our candidate name. Normally in the exam hall you're in, that will be there. You've got to put your first name and your last name on here, fairly obvious. And you've got to use a black pen. The reason you have to use a black pen is because the exams are scanned in and are marked by the examiners on a computer, not on the actual paper. It also says in the note here you can use the HB pencil, but only for graphs and diagrams, not all the rest of the answers. That's again because it is scanned in, and it can be quite tricky for the examiner if you don't use the right colour pencil, because when it scans in it'll fade a little bit. The paper is worth 80 marks. We have an hour and a half to complete it, so we're going to do this as a bit of a walk talk mock to go through how I would answer each of the questions in this exam. So let's get cracking. Oh, there is one last thing, you can't use a calculator in the paper. Anyway, question number 1. Computers represent data in a binary form. Tick one box to identify the statement about binary that is true. So it's important that you read each question very carefully. In this case, it's told us we can only tick one box. So if we tick more than one box, we're going to get a 0. So it's worth taking our time to read each one and check which one we think is right. So first option is binary digits can only be values 0, 1 and 2. The leftmost bit of a binary integer has the smallest value. Binary is used in computers because they can be on or off switches, and the smallest whole number you can store in 8 bits is 1. Well, I know, just right click here, I know that this one's not true, the top one's wrong. The second one is wrong because the leftmost bit is normally the biggest number. This one could be right. Let's check this one. This one's wrong because 8 bits is 1, 2, 4, 8. That's going to be much bigger than 1. So I'm going to tick this one here. So there you go, that's my first answer. Next one says complete this table by writing the missing denary values or 8-bit binary. So they all have to be 8-bit. So I can't put it less than 8-bit or hex values. So this one here, obviously this is the number 7 in binary. So that's 7 in hex. But actually in computer science, this is still 7 in normal numbers that we call denary or decimals. Put that down again, draw that on. There you go, 7. This one's asking us what 49 is in binary. So for that, what we'll do to make our lives a little bit easier, might not do this exactly like this in the exam, but you know that your number line is 1, followed by 2, followed by 4, followed by 8, followed by 16, followed by 32, followed by 64, followed by 128. So we'll just kind of quickly separate those out. So we've got a bit of a number line. You might not need that in exam. You might be able to work it out just using your head, and that's absolutely fine as well. Make sure any working out you do put in this area so the examiner can see it. Don't put it off on the side because the exam paper is scanned in the centre. Okay, put 128 again. So clearly it's not going to have any 128 in. It's going to have no 64 in as well. I think it's been helpful putting the dot in for me. It's going to have 32, yes. But remember, I've got to take away 32 from 49. Well, that leaves me with 17. So I'm going to have a 1 again here. Again, ignore the dots. It's just things that's been helpful trying to help you put grammar in. So I've got 32 plus 16, I've got 48. So there's not going to be a 0, there's not going to be an 8, there's not going to be a 4, there's not going to be a 2, and there's going to be a 1. Okay, so let's double check that back. I have 32 plus 16 is 48, plus the 1 is 49. I've got that right. This one, it gives us a hex, it's given us a binary. We need to work out what that is. So what we're going to do again is just put the little three hands. We can think about that. Well, this one's 64, so it's got a 64 in the number. It's got a 32 in the number. It's got no 16, no 8, plus a 4. Oh, it thinks I'm finished. Plus a 4, plus a 2. So I've got to add that up to work out the answer. Well, 64 plus 32 is 96, plus 4 is 100, plus 2 is 102. So I'll just put that in there, 102. There you go, and there's the answer. Again, you might not leave your working out there, but just double check it. 64 plus 32 is 96, plus 4 is 100, plus 2 is 102. And the last one, I've got to convert 244 to hex, or if I know how to, I can convert the binary into hex. Well, for me, it's easier to convert binary to hex, because I know that these two nibbles, so the 4 ones, and then the 0, 1, 0, 0 split in hex. So 1 plus 1 plus 1 plus 1, or another way of saying that in binary is 8 plus 4 plus 2 plus 1 is 15. But obviously it's in hex, so I can't write 15. So I count it with letters. A is 10, B is 11, C is 12, D is 13, E is 14, S 15. So my left-hand nibble is an F, and on my right-hand side I've got just 4, because there's no 8, 1 4, no 2s, and 1 1. Because again, that number gets split into 2 nibbles. So that is F4. And again, at that point in time, I would just take a little bit of time to go back through the answers I wrote down and just check I'm on the right lines, because they're reasonably easy marks that I can pick up towards the start of my paper. Let's go on to the next question. So we're on to C, which says tick one box to identify the largest file size. Now, I know that each point from bytes to kilobytes, kilobytes to megabytes, megabytes to gigabytes would divide them by 1,000 each time. So when I divide by 1,000, what happens really is I lose 3 zeros. So if I divide by 1,000, I'll lose those. So I'm just going to be left with 2,000. So I know already that 2,300 is bigger than 2,000, so it's not going to be the top one. Well, if I divide again, I'm going to divide by 1,000, so I'd lose the first 2 zeros, and then I'd be left with 2.3 megabytes. So 200 megabytes is clearly bigger than this one here. So it's not the top 2. It could be one of the bottom 2. I've got 200 megabytes or 0.1. But if I convert from gigabytes to megabytes, I reverse that process and multiply by 1,000. So if I was to multiply that by 1,000, I would actually get 100 megabytes. So I now know that 200 megabytes is the biggest size. Let's just put my little freehand. I can tick that box. There you go, let's answer that one. So we're on the part D. D says tick 2 boxes. So again, it's really important to read the question carefully, because even though it's only worth 1 mark, I've still got to tick 2 boxes. So I've got to identify which of these two are the same. Well, if I think about it again, I'm going to lose 3 zeros when I go up to the next level on this. Okay, so I've got 4,000. If I take that there and highlight it, if that was in kilobytes, that would be 4,500 kilobytes. So those top 2 aren't the same. Well, maybe the bottom 2 are the same. Well, 0.45 times by 1,000 will give me 450 megabytes. So those 2 aren't the same. So I'm getting a little bit closer. Well, to go from, this is now in kilobytes by saying 4,500, I would divide by 1,000 again. So I'd lose me 2 zeros, and then I would jump my decimal point here to give us 4.5. So I've now worked out that this one and this one are the same number. So again, just for that last bit there, I would lose these 2 zeros, but I don't have 3 zeros to get rid of like we normally divide by 1,000. So I can move the decimal place from the right hand side, the 5 in between, and that shows that the 2 that match are this one and also this one. So there you go, I'm done. Next question, complete the binary addition by adding these two numbers together. Okay, let's put my pen on again. So 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 1 is 0. Carry a 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 1 again out here. So I'm left with the answer is 0, 0, 0, 0, 1, 1, 1, 1. But I do have a little overflow, so I should show that the overflow did happen. And I just put a nice neat line to say that at that point, that overflow would actually be lost. Okay, so next what I'm going to do is to identify the binary shift that has been applied. So I'm not asked to perform one, I'm just told is it a left shift or a right shift. Okay, so yeah, I've obviously got identify the binary shift that has been applied to the 8-bit binary number here to get to here. So it's the first one, this one needs to get to this one. Well, I can see that on here I've got 3 1s, but on the other one I've only got 1 1. So I need some way which leaves me just with this bit, because I'm going to lose the 1 0 1 at the front. So here I've got 1 2 3 4 5, but here is 8 bits. Just count that 1 2 3 4 5 6 7 8. So to shift this 1 up to the very more significant bit, that's the bit on the left, I need to do a left shift, and the left shift needs to be of 3 places. So perform a left shift by 3 places to get from 1 0 1 1 1 2 3 4 to 1 1 2 3 4 5 6 7. Check that. Got the right number bits. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6. Yeah, that's the question done. Let's move on to the next one. So next one said a student is performing a range of actions on the internet. I've got a range of protocols. I've got to fill in the boxes. So there's some blanks here, and I've got to fill in the protocols that I know. Okay. Let's just read the question. Students perform a range of actions on the internet using their computer. A range of protocols are used for transmission of data by the student's computer and the web service they're accessing. Complete the table by identifying the most appropriate protocol for each of the tasks the student is performing. So requesting to view a news page on the internet. Well, think about it. News pages are just information. They're not particularly secure. So I'm going to put in here the acronym that I know is HTTP, because that is the name of the protocol. I could have put HTTPS, but it's not a web page that's going to be secure. This one, when a username and password enter their bank details, well, that's going to require security. So I'm going to have to put HTTPS in this case. Hypertext Transfer Protocol Secure. Next one, I need to download a text document from a web server. So I need to get that off the web server. So I'm going to use the File Transfer Protocol, or FTP. You could have put HTTP, HTTPS, because lots of websites would like to download it directly right using FTP. And last one, I need to check my emails. Well, there are 2 protocols that I know which I can use, are POP and IMAP. But I'm going to put the more recent one, which is IMAP, and we're going to leave POP off. So the next question we've got is some protocols have layers. Now, just in my head, I'm thinking a layer is a division of network functionality. Give 2 reasons why protocols have layers. Well, one is that each layer is independent, or layers are not relying on each other. And the other one I'm going to put down is I know because they can be edited separately. That's quite a good thing. So one layer can be changed without affecting the others. Now there's other availabilities on the mark scheme that you could have put down for that one. So there's things that you could have put down, separates tasks so they can be done independently. A developer can focus on one layer at a time. allows for standards and interoperability. Manufacturers can develop hardware to fit into one layer, and we could group similar protocols together. Like the protocols you learn about, a lot of them are what are called application layer protocols. Okay, next question, which is B. The student computer is part of a LAN, a local area network. The LAN currently only has wired connections. One characteristic of a LAN is that they're set up of a small geographical area. Well, I know that as well as being under a mile, but I know as example doesn't use that term, is that the hardware used within the LAN will be internal hardware, which means it will be owned by the company or student themselves. There you go, that one's done. Bosh. Let's go to the next one. Next one says, describe the benefits of the student changing their home LAN, because it currently was wired, to wireless. So I've got to think about why would it be useful. Now again, I need to kind of use the scenario. It's not just a generic kind of a good thing about wireless. It's a good thing about wireless. Yes, we need to say that, but we need to explain how that's useful to the student. Okay, so I'm going to put down one benefit, because I've used that in the thing. One benefit of moving to wireless over a wired network is that devices can be moved around their home without the need for wires. So I've kind of give like a point, but I've kind of linked it back in with being a home. So I kind of got that into there. That's why I kind of refer to that, yeah? Obviously I could have another benefit, is it's easier for the student to connect new devices to the network. I'm going to back that up. This could be useful. If the student has a friend come over, as they can provide the Wi-Fi key. Okay, now again I've got loads of space. I can write another one, so 2 is probably going to be what they're looking for, but obviously I have more. This time it doesn't say give a number, so I can go to town a little bit more. I'm also going to say that the home will be a likely small area. Well, we know it's definitely under a mile because of the LAN. A small area, so short wireless distance is sufficient. And that's because obviously if it was over a long area, the wireless signal will start to suffer a little bit. But again, in that box there, I can fill the whole space. I've not on this occasion, just so the video's not too long, but I could fill the whole space, and the examiner's got to mark all of that. And if I wanted to put more, I could put it on an extra piece of paper. In this case, I don't think it really needs it, but you can. So then it says, state 2 drawbacks of changing their LAN over to a wireless network. Well, 1, wireless networks are more prone to issues with interference. And another one I'm going to put down is that wireless networks have a lower bandwidth than a wired network. Just go and fix that little spelling mistake on that one. There you go. Let's scroll down a bit more. Because I only said identify, let's give a quick couple of statements. So binary numbers can represent different forms of data. One form of data is characters. Complete the description of how computers represent characters in binary using the given list of terms. It does say not all of them, however, will be used. So that's been really obvious to me, saying actually I don't need to have absolutely every single one on there. Okay, so some people read this and think, oh, I must fit all of them in there. No, we don't need to fit all of them into there. So we've got this little thing we're going to have a go at filling this in. A character set stores something of the characters. Well, it's going to be a word of some sort, because I'm on the bottom row. Look at me stores all of the characters that computer can represent. Each character is given a something code. One code? Maybe it's unique, because each one has its own binary representation. Lowercase and lowercase letters in a character set are given different binary code. One example of a character in ASCII. One example of character set is ASCII. This character set uses so many bits. Well, the version you're expected to know about is 8 bits. So I'll put 8. Again, if the character value for letter F is 70, then the character, so you've got to think about F, A, B, C, D, E, F, kind of count up A, B, C, D, E, F, G, H, I, J, K, L. So I've got a gap there of 6. So 70 plus 6 gives you one of the answers here. 76 is the answer I'm looking for. 76. Let's scroll down and have a go at the next question. Binary numbers can also represent images. The table shows the colours that are used in the image and the binary value for each colour. Table, you can read that yourself. The metadata states the image is 3 pixels wide by 4 high. The data in the file starts in the top left of the image and goes from the left to right, top to bottom. But then the question's not really that related, which is asking what is metadata? Well, I know that metadata is data about data. In this case, data about the image. That's one mark, probably a bit extreme, but you know, it just gets it over. In this, okay, that's fine. So a binary data stored of the image is this. A grid is given. Each square is 1 pixel. Write the color. So what it wants me to do is to use this very long, I suppose, string of binary characters. And then if I look at the size of it up here, each one is 4. So what I would probably think about is I need some way of highlighting, well, there's 4 here, then there's 4 more, then there's etc. to go through them colours. Okay, so essentially we get a few different colours. I'm going to put them in now. And again, you will scroll up and down. I'm going to make it a bit quicker for me, and it saves you a bit of time watching me scroll down. This is red, this is red, this is purple, this is blue, this is green. Don't know why that one's so massive. Resize the font a bit. Resize the font a bit. We've got blue again. Blue again. We've then got purple. We've then got purple. We've then got purple, because it's the same thing 3 times. We've then got red. We've then got green. It's been hidden there. And we've got blue. So we've got our colours. Now again, I did that quite quickly because I've done this question before, and I know the binary numbers that was given is what colours they give. Obviously, you would take the time going backwards and forwards. And again, you know, a little way you could do it is just put a comma after each 4 bits to separate, and that'll make your life a little bit easier rather than trying to look at all of that in one go, which is quite a lot. So maybe after 4 bits, like I said here. So like I said, maybe after 4 bits, just highlight it, and then you know with a comma, I can't quite do a comma here, going 4 bits, and then you could then highlight that with a comma, because in the exam you can use a black pen. Scroll down. A colour depth of 4 bits is used. This means 4 bits are used to store the colour for each pixel. State the number of maximum number, so the biggest number, of different colours. Well, I know in binary it's 1, 2, 4, 8. So we've got 1, 2, 4, 8. So 8 plus 4 plus 2 plus 1 gives you 15. But there's also a 0. So I know that 0 is also a possible colour we could use. So we're going to get 16 bits. 16 bits, 16 different colours. So make sure you don't make the mistake of 15, because 8 plus 4 plus 2 plus 1 is 15. But we've also got 0, which gives us 16. The next one says, the colour depth has increased to 2 bytes. So originally it was 4 bits to 2 bytes. Well, okay. 1 byte equals 8 bits. So 2 bytes equals 16 bits. So I know that that's now gone up by 4. So one is the quality of the image will have increased, which is one good thing of the image. The other issue I'm going to have, because of that, the file size of the image will also have increased. Now that I can get away with putting like fairly short answers there because the question says state two effects. So I'm not having to give massive answers. The word state or identify is like short answers. Okay, next one. A student has a text document and an image file that need to be compressed. So your brain's going lossy and lossless straight away. I need to think about. The student needs to reduce the file size of both these files as much as possible. Identify the most suitable type for a text document. Well, this one is going to be lossless. You can't use lossy compression on a text file as that means you would remove parts of the original file. So therefore, lossless compression is the best possible option. Okay, I'll just see anything else that's worth talking about from the exam board. They said that no data was lost with lossless. Okay, so let's just change that. The original no removal parts of word data, make it a slightly better answer, but the rest is absolutely fine. Next one is saying what we use here. So we're going to use lossy for this one. Now again, we're given a scenario, so we need to think about that. So lossy is useful in this case as it significantly, an example would have kept using that word significantly, reduces the file size more than reduces the file size more than lossless. The image file will lose some quality, but not enough so it's noticeable, if I could spell, to humans. Okay, so that's pretty decent answers for both of them to get us all the marks. Scroll down a bit. Again, tick one or more boxes. So we can tick a couple in this one if we want to. We can tick all if we needed to. I'm not sure that's going to be useful, but we can tick one or more. So some people will just put one across here, that leaves them a few marks. So let's have a look at this one. The threat is spyware. Well, anti-malware, pen testing, encryption, or firewall help in that case? Well, anti-malware for sure will help. And then with things like spyware, you could also have a firewall. However, this is the best answer, so you wouldn't necessarily need this one as well. Next one, I want to do a brute force attack. Well, a brute force attack, best way to do that is maybe have like a firewall of some sort. But also that would be useful, but again, you didn't have to put this one down, to be fair, was the idea of pen testing. Remember, pen testing is where you get someone to test your system so they could test your passwords to make sure the trial and error method like brute force won't work on them. Next one we've got is data interception. Well, anti-malware is not going to help with data interception. Pen testing is not going to really help with data interception. A firewall probably wouldn't help with data interception. So for that one, I'm going to put down encryption. And last one, SQL injection. Well, a firewall might help. Anti-malware is not going to help. Encryption is not going to really help. But pen testing would be quite useful. Not the best, but we've got to go with what the exam board say. So we've done those ones. We can, if you wanted to, you could have also put a tick in this box if you wanted to. So this exam board said you didn't have to put this one down, and you didn't have to put this one down, and you didn't have to put that one down to get the marks. They were just saying all those were possible options. Now name and describe one threat that's not there. So I've got spyware, I've got brute force, data interception, theft. Well, I know, top of my head, there's a few. I could have said social engineering, shoulder surfing, phishing, farming, hacking in general. I could have put viruses down, which is kind of part of malware. So, you know, like, but the virus wasn't down the left-hand side. I could put Trojans down, worms, ransomware, or physical threats. But I'm going to put the one I know the most about, which is a DOS attack. So again, when you're doing this, it is worth just thinking about what's the one I know most about. And for me, it's a DOS attack. And I can then explain a DOS attack is where you flood a server with illegitimate requests so that the server cannot deal with legitimate requests. Now again, it is really important you had to use the word server. If you didn't, that wouldn't give you the marks. And again, there was other answers you could put on, like I said, social engineering, shoulder surfing, farming, hacking, viruses, malware, trojans, worms, ransomware, and physical threats. Obviously, we don't want to make the video too long, so we're not going to go through all of them. There's your options. Right, scrolling down, we've got number 5, an artist has a computer that has a... Number 5, an artist has a computer that they can use to create images. The computer has both hardware and software. So it says the hardware includes primary and secondary storage. Explain why we need both primary storage and secondary storage. So in a way it's saying, why do we need primary storage? And it's saying, why do we need secondary storage? So let's do that. We need primary storage, such as the RAM and ROM. RAM stores the currently used data, instructions, parts of the OS. ROM stores the BIOS. And again, if I'm being honest, it's probably a bit overkill for 2 marks, but I'm just making sure I cover all bases. If I get anything wrong in there, at least the examiner can see I've got a few answers. And secondary storage is used to store data permanently, so it's non-volatile, and data that is not currently being used, because it also uses for virtual memory. Yep, that's a pretty good answer there. That should be being. Next one, give one example of a secondary storage device that the artist's computer will have, and an example of the data that will be stored on it. Well, I'm guessing they're going to have a hard drive of some sort, whether that's a hard drive or a solid state drive. So I'm just going to put a hard drive down. The example, when you use the term hard drive, we're talking about magnetic hard drives, so we'll leave that. A hard drive, an example data they might have in there is their operating system, their applications, they're going to have their files, in this case their images, because that's what they're working on. Okay, next question. The computer has virtual memory. The table has 4 statements of virtual memory. Not all of these are correct. Tick the true column for the statements that are correct. Now, because there's statements, there could be one, there could be more than one. So I've got to go through these and tick the ones that are right, but any that aren't right, I've got to rewrite it so it makes it true, because it might not be. Well, a section of primary storage. Nope, it's not a section of primary storage. I'm not going to write the full answer down, but secondary storage was what I'd replace in there. So it's a section of secondary storage. Data from ROM is transferred to the virtual memory. Nope, it's from the RAM. So I'd replace the word RAM in the full answer over here. Virtual memory is needed when the RAM is full. Oh, that's true. So I'm going to tick that one. And last one says data from virtual memory is transferred back to secondary storage when needed. Nope, because it is on secondary storage. So therefore, I'm going to have to replace that and say that it's transferred back to the RAM again. And again, I wouldn't just write the word RAM, I'd have to write the full statement just for the video. It makes it a little bit quicker for you guys. Next question. The computer has an operating system and utility software. State the need for utility software. Well, I know utility software is a piece of software which helps maintain the computer system. Get my spelling right. There you go, 1 mark done. Next one, see the artist uploads images to display on the website. There is a client-server relationship. Identify the computer that is acting as a client and why. And obviously I've got to say which one is the server and why. Okay, so the artist's computer is acting as the client machine because the client machine requests services from a server. So this is because the client or the artist machine is requesting services from the server. In this case, they are requesting to host their website on the web server. Okay, I could have other things that obviously performs users' actions, allows it to send the data, sends requests to a web server. Again, we kind of got that anyway. It does not store the actual website itself, and confirmation of the errors would be done by the server. That's a little bit over the top for GC level, but that is on the mark scheme. So next one says, identify the computer that is acting as a server in this case. Well, this is the web server, which was mentioned a little bit further up in the question somewhere. Okay, so it did say that's a client server relation to a website. Well, if it's on a website, it is using a web server. So the images are stored and uploaded to the web server. The web server deals with requests for web pages from clients such as the artist's machine. Okay. We can also web server executes a response to requests. The web server confirms if something's been uploaded or not, which is also true. Let's go. Next question. So next one says the artist is working for a programmer on development of a new piece of software. The software will allow users to edit images on devices such as mobile phones. They are considering releasing the software as open source instead of proprietary. Explain two benefits they get from having it as proprietary. Sorry, two benefits of having open source instead of proprietary. Well, the first thing we can have there is that authors can earn money by selling them for a fee. Okay, so two benefits of them doing it. Sorry, like I said, by using proprietary. If it's open source, often free, not always free, but can be free. Another one we can put down is no one can see the code, because the whole point of proprietary is that they can't see the code. It's only open source. They can see the code, which allows them more control over the IP of the image. Now remember, IP links in with copyright laws, so that kind of fits in for that one. Describe one benefit that maybe doing it as software as open source instead. Well, users get a copy of the source code for the software, so they can edit, improve, or adapt the code as they need for their purposes. Okay, you could talk about the fact that you could then release it for free, why that might be useful, but again, just to be clear, not all open source software is free. It's commonly free, but not always. Okay, let's go next one. So we've got a bit of a longer worded question. Now, I'm not going to write the full answer out on this because I'll be there for quite a while. What we're going to do instead is give you some things to think about. Well, the first thing is that these questions are marked on knowledge, application, and evaluation. It's marked into band. So this question here, if I scroll down somewhere, is 8 marks. So there's going to be a band, which is a lower bound, which is 1 to 2. There's going to be a middle bound, which is 3 to 5. We're going to have a higher band, that's 6 to 8. It's going to cover that range. To get in that top mark band, I need to give positives and negatives. I need to cover all 3 of these, and I must give an evaluation. So let's go through some of the possible issues. Legal side, DPA needs to be followed by the company. Otherwise, they could be fined. Because it says in the law that the data of the people, in this case CCTV people, must be kept secure. Under the new data protection, it says that customers, well, basically the data subject, but this data subject is the customers, must be informed of the use of CCTV. So you might have it in your school, but they're still going to let you and your parents know about this. The data must only only be kept for a specified time, no longer than necessary. Because again, that's what's written into the law. Okay. Other things you could see on there is you might say, well, actually, privacy issues, that's not fair on me. But thinking about it, the centre is private property, so you are choosing to follow their rules. It's not your house, so you can't really kind of get that one. And another positive, it could be used to identify thefts and criminal activity. So there's some general good points we could put into there. Let's go on the ethical. Well, ethical side, customers could feel safe as they know criminals are being monitored. Another point that a lot of people say, and a lot of my students would say, if users/customers are not doing anything wrong, do they need to be kept a track of? Some users might feel unsafe because they're being watched. Users could be unaware they are being recorded. There's not enough signs. That could be an issue. That basically there'll be a sign somewhere at the front of the store that says you're being CCTV, and also says by you coming to the store you are consenting to it, because we have to consent. Users do not know where the videos are stored. So that might be a data protection issue for them, that they don't have access to their data. We then got the other side, which is privacy issues. So users could feel it's an invasion of their privacy. Users in a public place can be legally recorded by anyone anyway. Again, there are rules on that, to be fair, so you can't just go and record whoever you like, to be clear on that. But it's saying that other people might record them anyway. Again, that is their privacy, and they can go against that. Users might feel they are being watched all the time, and users have not given their permission in writing. And again, it comes back to the thing that the fact we can know that it's there. Now, again, that's quite a lot of points there. So you would plan some of that at the top. I wouldn't put all of that in the middle of that kind of points, and then think, what are the best parts I know I can have a go at this, and make sure I give some positives and negatives, and where possible I keep linking it back to the shopping centre. My points there are reasonably generic, but it does fit in a little bit with customers, criminals, and all the things in there. I'm trying to get it back in about what they're doing. Actually, yeah, it should be an invasion of their privacy. Again, at the very end, maybe somewhere down here, I must have a conclusion. If I don't, I'm going to drop straight in that middle mark band, and then I'm limited to 5 marks. So always, even when you think you don't need a conclusion, definitely do put one in. Okay, next one says, a car comes with an embedded system. For example, parking sensors. Identify one other embedded system that can be in a car. Now, it's really important we read that question, because some people might think, oh, I'll put a washing machine down. Well, that's not in a car, so we can't put that down, yeah? So we're given an example of parking sensors. So we need to think of something that's a small system inside of the larger system that has a single or a limited number of purposes. Okay, so an example could be automatic lights, automatic window wipers, sat-nav, aircon, the radio system, lane assist, engine management system, auto park, cruise control, auto brake, follow me, or dash cam. But I think for me, I'm going to put cruise control. And the reason I'm going to put that down is an embedded system is a smaller system of a larger system which has a limited number of functions, and that's me done. Now that is the whole paper done. Now I know I went through that fairly quickly. Just a note, there is additional paper here. If in a question earlier on you want to use additional paper, that is fine. Just make it really obvious to the examiner you've used that, because they're not going to read every page unless you let them know they should read every page. So make sure you cover that as well. Again, like I said, there is our little two things. There's an online course, which I'll put a link down below, and there is a revision session which on 2025 on April the 15th and 17th from 4 till 5:30, and it's £40 for both sessions, which is 3 hours of expert time from a very, very good computer science teacher. Well done for watching, and we'll see you in the next one.